Hi guys, welcome back to my channel. Today we're going to have a look at some transformations. So we've looked at different kinds of transformations for parabola functions before, and a lot of those transformations we can actually see in other graphs as well. I think it was the famous Eddie Wu who once said, if there's some sort of geometric relationship, then behind that geometric relationship there's this algebraic relationship that's underpinning that. And we've seen that now a couple of times. So we've used these variables before. So A, we've used in the past to represent our dilation or reflection factor. C, we've used to represent our horizontal translation. And D, we've used to represent our vertical translation. So for a hyperbola graph, what do each of these transformations look like, and how are they different to the transformations that we've seen in parabola graphs? So let's first play with this value for A. Now, like I said before, when we're looking at values of A, that's generally our dilation factor. So dilation meaning it's going to get bigger or going to get smaller. And if you've watched the past or previous video that I've filmed on hyperbolas, then you saw that when we had a large value for A, then this line tended to become a little bit further or wider from that origin. What we haven't seen before is we haven't seen this value for C or for D and how those transformations affect the hyperbola graph. So let's start off with this factor A. So if I press this play button here, this is going to increase this value of A, and we can start to see what happens as this value of A increases. So as we saw before in the previous example, this starts to go further and further out from the axes. So this becomes wider and wider. This does not change, and I'll zoom this out to prove it, this does not change the position of our vertical and horizontal asymptotes. So it's still going to be approaching the x and the y axis. The only difference is that it's gotten a little wider from that origin. So that's our dilation factor when A is going to be greater than 1. So as we get back smaller and smaller and smaller than 1, this starts to get closer and closer and closer to that origin. If I was to continue on this path into the negative, so with the parabola, when it was a negative, this flipped the graph. So let's see how this affects this graph here. So again, this graph is reflected and it completely flips, okay? And again, if we increase, so this is increasingly negative, this is getting increasingly further and further away from the origin. But again, notice, look, the horizontal and the vertical asymptotes have not changed. Okay, so A, that's our dilation factor, and when it's negative, that becomes our reflection factor. All right, so let's pop this value back to 1, and let's have a look at these other values. So C, in this case, this is our our horizontal translation. So think about what's happening here. If I was to divide 1 by x, I don't have a value when x is equal to 0. We can't have the denominator equal to 0. So if I was to add 2, this value would now change. So we couldn't have x equal to negative 2, because if x was equal to negative 2, then the value of the graph would be 0. So just like we've seen in previous examples with this horizontal translation, it actually moves the graph in the opposite direction to what we think. So we're starting off with 0. As we increase this value c, right? So that's going to move that position of that x under which this value is going to be undefined. And so it's going to shift this, or we should see this shift this to the left. So there you go. As we increase this value of c, it's shifting to the left. And like I said before, that goes back to that idea of dividing by 0. We can't divide by 0. So this just moves where that divide by 0 comes from. Because if we have x plus 7, this will become now negative 7 as the value where this point no longer exists. And so this is shifting our vertical asymptote. So for this function, our vertical asymptote is now going to be at negative 7. Okay, so it's shifting to the opposite direction to what we think it's going to be. So then let's see what happens as we shift c back. If we shift c into the negative values, this is going to move to the right. So that is our horizontal translation. And again, that's going to affect the position of the vertical asymptote, and it will be the opposite to what we think it's going to be. All right, so let's set this back to 0 now. And let's have a look at our vertical translations. So vertical translations are generally pretty straightforward. We've seen in the past, if d is a positive value, that's going to shift the graph up. And if it's a negative value, it's going to shift the graph down. So let's have a look. Yep, so as we suspected, as D becomes positive, more and more positive, it's going to shift the graph further and further up. And then as D becomes negative, it's going to shift that graph further and further down. So in this case, we are now shifting the position of the horizontal asymptote. So when D is, let's change this to -4. So when D is equal to -4, our horizontal asymptote has now changed to Y is equal to -4. So that's how we use transformations to draw some graphs. So let's go ahead and let's find a question that we can work through. So transformations of the hyperbola, I've just summarized those three values for us there. So we're going to sketch the graph of y is equal to 2 over x plus 1 minus 3, and we're going to state the equations of the asymptotes. So let's go ahead and let's draw in this graph, and this is going to be a little bit difficult for me to draw by hand, so we will double check our answer in decimals at the end. So the first thing I'm going to look at is I'm going to look at this value for a. Now, compared to the original parent function, so original parent function is 1 over x, this is going to be slightly wider, slightly bigger, or slightly further out. But this does not change the values of the horizontal or vertical asymptotes. So this will just, rather than looking like that, it's actually going to look something like that. So it's going to be further out from that axis, not actually going to change the asymptotes. So that would be our A factor. And I need to make sure that I draw this going the opposite way as well. So we'll make sure that's going out. So that's our first transformation. So let's have a look at this next transformation. So the horizontal translation. So this is this value here, C. So when we have x plus 1, x cannot be equal to -1, because if I was to substitute -1 into this equation, then we would be dividing by 0. So this means this asymptote is going to actually be moved to -1. So let's draw that in. So now this will have shifted this graph here that was originally in black, that will have moved that over to this point here. And again, I'm going to try and keep relatively far away from that axis because that value is bigger than, that 2 value is bigger than 1. Okay, the last thing that we need to do is going to draw in the horizontal asymptote. So this value for D here is equal to -3. So that means that my graph has shifted down 3. And so we're going to see our horizontal asymptote down here. So let's draw that asymptote in. So now what I'm going to do is I'm going to use these new asymptotes or these new lines that I've created to help me draw my graph. So let's clean this up a little bit. All right, so now that I've cleaned that up, let's go ahead and attempt to draw. So this is my vertical asymptote, so I should never touch this. And again, it might get very, very close, but it's never going to reach. Okay, this is going to be a little bit further away from that axis because of that dilation factor. And that's my horizontal asymptote. So again, it'll get very close to the end there, but it'll never reach. So I think for our next question, why don't we try drawing in our asymptotes first, and then it will be a lot easier to draw our hyperbola. Okay, so this last question here, state the equations of the asymptote. So we've got our vertical asymptote. Now remember, when we have a vertical line, it's always x is equal to something, and in this case, it will be x is equal to -1. Now for our horizontal asymptote, remember when we have a horizontal function, it's always y is equal to a constant, and in this case, our constant is going to be equal to -3. Alternatively, if we couldn't determine that from the graph, what we could do to find our x and our y asymptotes is we could substitute in x is equal to 0 and y is equal to 0, and that should be able to tell me where those points are going to be. Let's go ahead, let's do another question. So for our second graph here, what I want to do, I think it will be easier if we draw those asymptotes in first. So let's go ahead and have a look at those horizontal and vertical translations. So this first value here, this is going to be my horizontal translation. And so we can't have a value for this denominator equal to 0. So my new value of x must be 8. Because if I substituted 8 minus 8, I would get 0. And so this must be the location of that new asymptote. So let's draw this in. And because this is my vertical asymptote, vertical equations have vertical functions have an equation of x is equal to something. And in this case, our constant is going to be 8. So now let's go ahead and do the same thing for our vertical transformation. So again, if I wanted to find this intercept, I could just go ahead and substitute x is equal to 0 in here. But let's go ahead anyway and just pop this in. We know that for these vertical translation, it's going to be pretty straightforward. So we're going to move up 2. So that means our new function is going to be y is equal to 2, and we can draw in our horizontal line at that point. So the last thing that we need to do now that we've got our asymptotes drawn is we actually need to draw our function. So in this case, looking at this dilation factor, it's got a factor of 3. So that means it's going to be slightly further away from here compared to y is equal to 1 over x. And also it's a negative, so it's going to reflect, it's going to flip. So let's go ahead and draw this in. So we'll start off, we want to be pretty close to the axis to start off with, and we're getting further and further and further away. Now this one is slightly, the magnitude is slightly bigger, so we'll go slightly further out. There we go. And then drawing our other line through at about here. All right, so those are our 2 lines. So let's go ahead. So this was our second one. This was our first equation. Let's go ahead and let's draw those in Desmos to see if we got it pretty close. So this is our parent function here, y is equal to 1 over x. So let's pop that first equation to check. So we should have shifted that down and across to the left. So let's double check. So this was our first equation here, and indeed we have shifted down and across to the left. Now looking at this second equation, we should have moved it up and to the right. So let's double check. Okay, so indeed we have moved over to the right and then up 2 units. So that's how we use transformations to draw a hyperbola function rather than plotting those values in a table. All right, guys, I will see you in the next one. Have a good day. Bye.